Okay, welcome back. Sections on transformations of functions 1.6. So what we want to do is produce a zoology of functions, and then we can kind of move them around in space via translations or transformations. Okay, so we want first to introduce sort of the most common functions, and go from there. Okay, so the graphs of common functions. Okay, so the most common we've been dealing with is the equation of a line. So you have something like this: y equals mx plus b. In all various forms of that, obviously. So you have horizontal lines, vertical lines. The sky, this is literally y equals x. It's just a diagonal through the origin. We saw the absolute value function back in the beginning lectures. So this is y equals absolute value of x. Parabolas. Okay, so they have this u shape to them. So y equals x squared. Root functions. Okay. And what they are is basically just half of a sideways facing parabola. So you can imagine the other half is down here. Just don't draw that part and draw the top part. Okay, so that would be y equals root x. And of course we have the cubics. Okay. So they look like this. They have odd symmetry. And it looks like I have one more in my notes. Cube root function. Okay. So the cube root function is basically just the reflection of this function about this line. Okay, so it'll look like this, more or less. Okay, so y equals cube root of x. And it also has odd symmetry. Okay, so given some sort of function, with these as kind of their basic elements. So for example, maybe you'll see something like y equals negative x minus 2 squared plus 3. Okay. This thing is related to this guy right here. And it turns out you can graph this thing if you just move this thing around in the xy plane in a particular order. So you don't need to use a t-table, you don't need to bust out your calculator, you can just handle it doing transformations. Okay, so that's kind of what we're after. We want to learn how to graph these kind of things without going and relying on our calculators, etc. Okay, so there are about 4 or 5 or 6 different kinds of transformations. And the first one we look at are the verticals. Okay. Turns out there's a particular order of transformations that you have to follow. It's kind of like in math, you get accustomed to thinking of things having symmetry to them, like 3 times 2 is the same as 2 times 3. You can do it in either order, it doesn't matter, but here order becomes really important. It's kind of like what I said before with you have to put on your socks before you can put on your shoes, and likewise you have to take off your shoes first before you can take off your socks. Well, order is very important here in this setting. Okay, so the first kind of transformation are the vertical shifts, and basically you'll see your fundamental graph written out, and then you'll either have a plus or a minus some positive constant. So if it's plus something, that's going to shift it up. If it's minus something, it's going to shift it down. Okay, so problem 54, the exercise wants you the graph g of x equals x squared minus 1. Okay. And I believe they want you to first graph f of x equals x squared, and then use the transformation to get g of x. Okay. So f of x equals x squared is one of our fundamental graphs. We should have no problem graphing that. If you need to get a couple points, you can do a t-table for just f of x. For g of x, you need to do translations. Okay. So maybe negative 2 is 4, 0 is 0, 2 is 4. Okay, so we have this graph. Let's see if I have a different color pen to work with. Probably not, right? All right, so this tells me I need to shift down by 1 unit. So what I'm going to do is basically just move all of these guys down one place and redraw my graph. Okay, so this would be g of x. And you can see it's a lot easier than doing a whole nother table, or even worse, having to bust out your calculator and doing that business. Okay. One more, 107. Okay, this one's based off of the cubic function. So 107. And it's the same game. They want you to first graph the cube root of x, and then do the appropriate transformation to get g of x. Again, if you want to, you could do a minor t-table. Use some values like 8. The cube root of 8, you know, okay, is 2, and then 0 is 0. Negative 8 is going to give me negative 2. Okay. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2. 0, 0, and then 1. Whoops, I went the wrong way, right? So negative 8, negative 2. It's down here. 1, 2, 3, 4, 5, 6, 7, 8. Positive 2. And then I connect my dots. Okay. So to get my new graph now, I have a shift up by 2. So you can literally just take each dot and shift it up by 2. And 2. I need 2 more tick marks for that to work. And then connect your dots, and you're good to go. Okay, so not exactly perfect, but that's the idea. Okay, so that's our first transformation. The next one, you know, if you can move it up and down, obviously you move left and right, so that's going to be a horizontal shift. Okay, so in these cases, you'll see something added inside the guts of the function, so to speak. F of x plus c is going to shift in the negative direction. In other words, shift left this time. So you may think, oh, if it's plus, it's going to be like this, and it's going to shift up. But that kind of intuition is not going to work for you here. If it's minus, then it's going to shift it to the right. Okay. And this time we have kind of a fabricated equation or a graph in the book for number 20. I'll try to draw it as well as I can. I need 5 tick marks on the negative arm of the y-axis, 5 tick marks on the positive arm of the x-axis, and then I'm going up 2. Okay, the original graph goes 1, 2, 3, negative 4, 0, and then negative 2, negative 2, I believe, and then goes through 0, 0, and then 2, 2, and then 4, it must be 0. So it looks like this kind of weird thing here. Right, so the question wants you to draw then f of x plus 1. Okay? So if you add it, if you're adding 1, that's going to shift it to the left. So you need to take everything and move it over by one place. So I'm moving this point over by 1, and I move this point over by 1, move this point over by 1, moving this point over by 1, and likewise this point. So it just shifts the whole thing over one place. Right? This will be our sort of answer in red. Okay. Let's look at the horizontal and vertical shifts kind of mixed together then. So section 4, horizontal plus then a vertical shift. The order of operations here is you want to do the horizontal first and then do the vertical. I don't think it'll matter, but you want to get used to doing it this way. So sometimes you can literally take your socks off before your shoes and it's not going to affect you. But that doesn't mean it's going to work all the time. In particular here we have h of x equals the absolute value of x plus 3 minus 2. Okay. And in particular the common function we're dealing with here is this guy, the absolute value of x. Okay. Right, so there's two thingamajigs going on. There is, in the horizontal domain, we have a shift of 3 to the left. So you can go left 3. And then this over here, the minus 2, is going to shift it down 2. So down 2. All right, so let's draw. We'll first draw the absolute value of x, and then we'll draw the new function as well. So I'm going to need 1, 2, 3, 4. About 1, 2, 3, 4. 1, 2, 4. And then I decided to go 1, 2, and 1, 2. So again, you can do a t-table for your original function, f of x equals absolute value of x. Okay. And I'll try -2, 0, and 2. So that give me 2, 0, 2. So -2, 2, 0, 0, and 1, 2, 2. Okay. And the graph looks like this. Okay, so the new graph, again, I'm going left 3, so 1, 2, let's say another tick mark, 1, 2, 3, but then I'm going down 2, so 1, 2. So this dot is being moved over to this position. This dot, left 3, 1, 2, 3, and then down 1, 2, is being moved here. And then finally this guy, left 3, 1, 2, 3, and then, whoops. 1, 2, 3 is right here, and then down 2, so 1, 2, we'll put that guy right there. Okay, and then connect your dots, and you got it. Okay, the next kind of transformation are reflections about the x and the y axis. So let's take a look at that stuff. So if you see a negative on the outside of your common graph, on the outside of your function, it's going to reflect it about the y-axis. So I'll indicate that with this symbol. So a little loop about, oh, sorry, the x-axis. I don't know if I said y, but there's a little loop around the x-axis. If it's on the inside, if they put the negative in the guts of the function, then you're doing a reflection around the y-axis. So let's put a little loop around the y. Okay, so let's look at number 24. This is another one. They sort of fabricated a graph, and they want you to redraw it. So in particular, they want you to draw g of x equals negative, what is it on the inside? Yeah, sorry, f of negative x. Okay. So f of x is that, is this guy, so I need 4 tick marks, 1, 2, 3, 4. 1, 2, 1, 2, 1, 2, 3, 4. So here's the original graph. If it's on the inside, again, it's a reflection around the y-axis. Okay? So it's going to take this point and make them over here. It's going to take this guy and put them over here. This guy will stay where it is. And then it's going to take this guy and put him over here. And it's going to take this guy and swing him over here. Okay, so the end graph is the red thing. Okay. Let's look at the next kind, vertical, the last kind, I believe, the vertical stretch and shrink. Okay, so these guys will smush it or stretch it out, or smush it or stretch it out in the vertical or the horizontal direction. So I guess we want to look at the two different kinds of versions. The first version of the stretch shrink is the vertical. Okay. Okay. And basically what's going on is you'll see you'll have your y equaling c of f of x, and the whether it's a stretch or shrink is dependent on the c value. Okay, so if c is greater than 1, you'll have a stretch, and if c is greater than 0 but less than 1, you'll have a shrink. Okay, so let's take a look at number 28. And they want you to draw 1/2 of the original function, which is similar to the last function we were drawing, just the upside down version of it. Looks like it goes to 4. 1, 2, 3, 4. 1, 2, 3, 4. It goes up to 2. And it's going down to 2 here. And what's going to happen is it's going to squish all of your y values by 1/2. It's going to factor all your y values by 1/2. So if you have this point here is going to be 2, -2. Right? So 2, -2. So the end result of multiplying this function by 1/2, it's going to cut this -2 in half. So you're going to end up with this should be negative, sorry. You're going to end up with -2, -1. Okay, so it's going to end up right here. The end result is it's smushing the graph. Let me put this in red. Okay. This point right here is at -4, 0. And again, it's 1/2 times basically the y coordinate. So 1/2 times 0 is not going to change its position. And same for here. The original coordinate is 0, 0. When you multiply 0 by 1/2, you're going to get 0 again. And then this guy here is at 2, 2. So when you multiply this coordinate by 1/2, you're going to get 2, 1, which is right here. And then finally, this point is 4, 0. If you multiply 0 by 1/2, it's not going to move. So again, the idea is if you have a fraction, it's going to kind of smush the graph down because it's cutting all of your y coordinates in half in this case. Okay, so that's the vertical version. We also have the horizontal version, and in that case you'll see the constant is on the inside of the function. So this is section 7. The horizontal stretch shrink. And so we'll have y equals f of c times x. And the characteristics are different than here. They're kind of flipped. So when C is greater than 1, you'll have a smush, and when C is between 1 and 0, you'll have a stretch. Okay, so I'm not making a mistake. It literally is opposite. So what did I say? When C is greater than 1, you'll have a shrink. And then when C is in between 0 and 1, you'll have a stretch. So let's look at our example. This is example 7. And let's go at it. So we'll have 1, 2, 3, 4 tick marks on each arm. 1, 2, 3, 4. Yeah. Oh, I'm going to need another piece of paper. I'm sorry. So again, the original graph, and then I'm going to draw the transformations below it on 2 separate systems. Okay, so the points, I have negative 4, 0. I'll have 2, 4, I believe. 1, 2, 1, 2, 3, 4. Or negative 2, 4. We have 0, 0. We'll have 1, 2, negative 2. And then I'll have 4, 0. Okay. And it's curvy, it's smooth like that, and then it has this kind of cornery type behavior in that interval. Part A, they want you to draw f of 2x. Okay. So what is that going to do? That's going to smush it, okay, by a factor of 1/2. So you're basically manipulating the x coordinates in these cases, and so it'll go from negative 4, 0 to negative 2, 0. Okay? And then it'll, up here it's negative 2, 4. Now it'll be negative 1, 2, 3, 4. Okay. 0, 0 will remain in the same place. And then instead of 2, negative 2, it'll be 1, negative 2. And then instead of 4, 0, you'll have 2, 0. Okay, so it'll look like this. And again, what's this thing doing? You're ending up multiply the x coordinate by a factor of 1/2. Okay. Part B, then, they want us to figure out h of x equals 1/2 x, f of 1/2 x. And that will be the stretch version of all this. So let's take a look. We need a lot more room. Its end behavior is to multiply the x coordinates by 2. Okay, so you just take the reciprocal. Right, so instead of negative 4, 0, you'll have 1, 2, 3, 4, 5, 6, 7, 8. Negative 8, 0. Instead of negative 2, 4, you'll have negative 4, 4. 1, 2, 3, 4. 1, 2, 3, 4. Instead of, well, 0, 0 will stay the same, because 0 times 0 is 0. And then instead of 2, negative 2, you'll have 4, negative 2. 1, 2, 3, 4, 1, 2. And then instead of 4, 0, you have 8, 0. 4, 5, 6, 7, 8. Lines. And there it is. Okay. In the end, we want to combine all of these guys together. In practice, it's never, the more complicated it gets, you'll sort of delegate that to your calculator. It's just like when you're multiplying bigger and bigger numbers. Okay, I'm not going to do this by hand. I'm going to pull out the calculator. But you should be able to do just very simple compositions of transformations. And first we need to just note the order of operations. So we have a sequences, of transformations. And our order of operations, it's like, please excuse my dear Aunt Sally, right? It's that kind of idea. You want to start with horizontal shifts. Then you'll do your vertical and horizontal shrink stretches. And it won't matter which order you do those in. Vertical first or horizontal first, it doesn't matter. Then you'll have reflections. Again, it won't matter if you do the X or Y reflection first. And then finally, do your vertical shifts. Okay. So I remember it by thinking Hoser V. Hoser, like in Canada, they call people hosers. And then V, I just tack a V on it. I don't know. You got to make up your own because nobody's really thought it through. I haven't really thought it through, but Hoser V works for me, so I don't really need to think it through any more than that. Anyways, let's take a look at number 60 in the book. We have f of x equals x minus 1 squared plus 2. I need to, I guess, first identify its common form, and I mean the sort of the prime form is an x squared form. It's a parabola. Okay. So first identify the horizontal shift. So first there is a shift right by 1, and then this thing will be a shift up 2. Again, if you want to, you can do a table of values for the fundamental graph x squared. So negative 2, 4, 0, 0, 2, 4. So that'll look like this. Okay, and then we can show each individual shift here. I'm shifting right by 1, so all these dots are moving over by 1. Or, whoops, that's the left way, so I want to shift right, sorry about that. So go over here, this guy goes over here, this guy goes over here. So that's from the first shift. And then the final version, we need to shift up 2. So I'll go 1, 2 here. 1, 2 here, and then 1, 2 here, and then that should be our answer, so to speak. Oops. Let's look at another 74, and we have h of x equals square root of negative x plus 1. Okay. Our fundamental graph is a square root function, so we'll have y equals square root x. This is just a translated version of this. So you think 0, 0, 4, 2. I don't know how many points we need. We'll just go with that. 1, 1 if you want to put in another one. Right, so the original form 0, 0, 1, 1, 2, 3, 4, 4, 2 is this guy. For our new function, what do we need to do? So horizontal first, so I have a shift to the left by 1. And then your shrink stretch is not here. Reflections, so there's a y-axis reflection. Okay, so again, you could sort of do it step by step. First, shift all these points over by 1. And all that sort of in a dashed form, so it's not too ugly. Then we want to do a reflection about the y-axis. Okay, so this guy will go this guy will go here, this guy stays where it is, this guy, where is it at? 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, so go there. That'll be it. Okay. Okay, let's try one more, and then we'll call it a day for this section. 106. We have h of x equals negative x minus 2 cubed. So the original function is just the cubic function. And then, again, if you want to get some points going, what do we have? Negative 1, negative 1, 0, 0, 1, 1. So negative 1, 1, 0, 0, 1, 1. And it looks like this originally. Okay, so going back up here, what do we have? We have a shift right by 2. That's our horizontal. And then on the outside, we have a reflection about the x-axis. So first, shift right by 2. 2. 1, 2. 1, 2. And then we have our x-axis reflection. Okay, so this guy's going to go here. This guy will stay where it is. This guy will go here. And then that'll be our final graph. Okay, whoops, I did the cube root function. Okay, so, ugh, so bad news. Sorry about that. Let's try it again. Okay, so this, what did I draw? I just drew h of x equaling negative cube root of x minus 2. Sorry. I was thinking in the beginning of the lecture, I accidentally may have called this the cube function, but it's actually the cube root function, and then I started thinking cube root function. Okay, so I apologize. Let's try it again. 106, h of x equals negative x minus 2 cubed. Okay, so again, it just so happens the cube root function and the cube function have the same points. If you were to do your t-table, so it would be negative 1, negative 1, negative 1 cubed is negative 1, the cube root of negative 1 is negative 1, 0, 0, 1, 1. So let's draw that. And actually, it looks like this, right? Sorry about that. Okay, so again, we want a right shift of 2 and then an x-axis reflect. Okay, so let's see. So first we go right 2. So I'm going to have to put 2 more points in here. Do this in blue. 1, 2, and then 1, 2. So our next graph looks like this. And then we want to do an x-axis reflection. Okay. So this guy is going to go here, this guy stays the same place, and this guy goes here. Okay, so at the end of the day, we have this guy as our graph. Okay, that's about it.